Welcome to Marine Gurukul video series. In this video, we shall learn to draw some sketches. The purpose of this video is to basically stepwise demonstrate as to how the sketches can be drawn, because today when we see a complete picture, the student usually is at loss as to from where to start and in a systematic manner complete the drawing. So the objective of this particular video shall be to basically run through the drawing of the sketch in a stepwise manner. Through this video, we shall learn to draw an elevation or the profile of a general cargo ship, showing the location of the cargo holds, engine room, peak tanks, DB tanks, hatchways, and position of the bulkheads. We shall also learn to draw the elevation of a typical crude oil carrier, that's an oil tanker, showing bulkheads, cofferdams, pump room, engine room, bunker and peak tanks, cargo tanks, and permanent water ballast tanks or the segregated ballast tanks. Also to learn to draw the plan view of a tanker, showing the arrangement of cargo tanks and the water ballast tanks. For better understanding of this particular video, please do watch and understand our earlier video on ship's GA plan, that is ship's general arrangement plan, before going ahead with this one. Let us start by drawing the elevation of a general cargo ship. First, we shall draw the outer boundaries of a ship in its profile view, which shall be more or less similar for all types of cargo ships, barring little difference here and there. So we can see how the outer boundary is being drawn. Here is the stem of the ship, followed by the bulbous bow. You can see on the screen as each of them are coming up one by one. Then the keel of the ship, then the forecastle deck, coming down to main deck, and then in the after part, closing this diagram with the ship's stern. So this is the outer boundary of the ship as it is seen in the profile view. Then we have the forward mast here. In this ship, we are drawing aft superstructure or aft accommodation. So you can see the accommodation coming up here. You can see the accommodation being drawn in steps. Then you will have the main mast above the accommodation, and you have the funnel here in the profile view. Then we have the rudder followed by the propeller shown up here. Now this ship will have a bulkhead in the forward part called as the collision bulkhead. So it's a transverse bulkhead running from side to side. And likewise, there will be another bulkhead in the after part called as the aft peak bulkhead. Now, the double bottom of the ship will run only between these two bulkheads. Double bottom does not extend into the peak tank. So please make a note of it. So double bottom does not extend into the peak tanks, fore peak and after peak tank. It is from the collision bulkhead to the aft peak bulkhead. Then if we have the aft machinery space, then there can be another bulkhead here containing the machinery space or encompassing the machinery space. Now, this is primarily the cargo space of the ship. The cargo space has a second safety barrier by way of a small void space in the forward part here and another void space in the after part here, separating the cargo spaces by a second bulkhead, or providing a second line of safety to the cargo through a second bulkhead. And the void space is called as the cofferdam. So we have the cofferdam in the forward part here. We have another cofferdam in the after part here. We shall be labeling all these parts in a while, don't worry about it. Then this is now the space left for carrying the cargo. And this can be divided into smaller compartments called as the cargo holds, depending on the requirement, by transverse bulkheads. So we can have the transverse bulkheads dividing them into smaller compartments. In this case, we have divided this space into 4 cargo holds. Each of these cargo holds would have an opening on the upper deck for the cargo to be loaded and discharged, and that opening will be protected by a hatch combing and having a provision for closing through hatch covers. So each of these cargo holds is serviced by a hatchway, hatch combing, and a hatch closing arrangement or the hatch cover. You can see the hatchway protection here, all showing up in the profile view. Then if the ship has a twin deck, then a twin deck also can be shown. We can see here there is another second deck coming in here. Now this twin deck also would have the hatchway opening right beneath the hatchway opening on the main deck. You can say the twin deck opening being now shown up here by lightening of this, making this line lighter. Now, general cargo ships usually have their own cargo handling gear. Modern ships may have cranes, or you may still have derricks. I have drawn the derricks because they are easier for drawing in the sketch. Otherwise, you can draw cranes also. So here you see the Samson post for the derrick, and you have a set of derricks here. Another set of derricks with Samson post, another one out here in the forward part. Now, with all this, what we have shown is what would be there in the profile view of a general cargo ship. And now, having drawn this, now we start with the labeling of the parts. The labeling of this diagram obviously is going to give us another opportunity to learn each of the parts again. So we have the keel of the ship, then we have the inner bottom or the tank top, and the space between the two bottoms is the double bottom space divided into tanks called as the double bottom tanks. The forwardmost bulkhead we have already said is the collision bulkhead, and the tank forward of it is the four-peak tank. Likewise, this bulkhead aft is the aft peak bulkhead, and we have the aft peak tank aft of the aft peak bulkhead, but this tank may not extend right up to the main deck. It may terminate at the second deck or any point above the second deck, and this space here may be used for the steering gear. Here we can have the steering flat of the vessel. Then we have the machinery space or the engine room here. Then we have these two void spaces called as the cofferdams. So here is the cofferdam aft. We have the cofferdam forward. Then these cargo spaces are in the lower part, they are the cargo holds. So this is number 1 cargo hold. This is number 2 lower cargo hold, number 3, number 4. Numbering is from forward to aft. So we have number 1 lower hold, number 2 lower hold, number 3 lower hold, number 4 lower hold, and their respective twin decks, number 1 twin deck, number 2 twin deck, number 3 twin deck, and number 4 twin deck. Now we come to labeling the parts on the deck, above the deck. Here we have the forward mast. Then we have the Samson post here. If there is a crane, then there could be a crane post. Then we have these derricks, or in lieu of derricks, you may draw a crane. Then we have these hatchways, hatch combing, and hatch cover arrangement out here. Then we have the superstructure, funnel, and the main mast of the ship. So this is how we have labeled, and during the labeling, we have been able to revisit all the parts. I hope you will be now comfortable in drawing the elevation of a general cargo ship. Now we shall learn to draw the elevation of a crude oil tanker, a double hull crude oil tanker. Now first we shall draw the outline of the ship in a profile view, which is common between the general cargo ship profile and this crude oil tanker profile as well. So we first draw that part which is common. So we start with the stem of the ship, bulbous bow, keel, forecastle deck, coming down to main deck, upper deck or the main deck, and closing the outer boundary by the ship's stern. Then we have the forward mast coming up. We have the superstructure aft. It's the same thing which was there in the file of a general cargo ship which we just learned. We have the main mast and we have the funnel. Then we have the rudder and the propeller. We have the collision bulkhead coming up here. And we also have the aft peak bulkhead coming up. Now this part is common to what was there in the general cargo ship, and we also have then the double bottom extending from the collision bulkhead to the after peak bulkhead. Then we have another bulkhead encompassing the engine room or the machinery space. Now, whatever we have drawn so far is exactly the same as was in the elevation of a general cargo ship. So whatever is common, let's label that first, which we have already done earlier. Let's do the labeling once again. We have the keel of the ship, inner bottom or the tank top. Then we have the collision bulkhead. We have the forepeak tank. We have the aft peak bulkhead. We have the aft peak tank. And above that, we have the steering flat. Then we have the double bottom tanks between the two bottoms. We have the engine room here or the machinery space. Then we have the forward mast. We have superstructure. We have funnel. And we have the main mast. Until now, it is exactly the same as the profile of a general cargo ship. The changes would be in this part, that is the cargo carrying part of the vessel. Now what we have done is whatever was common has been drawn, labeled, and now that labeling has been put in the background so that we can now focus on the labeling that will be more or less exclusive to crude oil tanker or an oil tanker. Now, like the general cargo ship, there would be a void space separating the cargo spaces from the forepeak tank. So we have a cofferdam. Cofferdam forward was there in a general cargo ship as well. There was a cofferdam here, if you remember, in the general cargo ship. But in these tankers, usually we have a cargo pump room here, and that cargo pump room itself also acts as the cofferdam space. So we don't have a cofferdam in the after part. The cargo pump room provides the necessary segregation of the cargo space from the machinery spaces. So here we have the space which is marked as the cargo pump room. So whereas there is a cofferdam in the forward end, the cofferdam in the after end is now replaced by the cargo pump room. Then we have in the engine room on the sides and the double bottom, beneath the engine room and under the pump room, we can have the bunker tanks, bunker oil tanks based on the requirement of the ship. They can be subdivided into smaller tanks need based. Then this cargo space from the forward bulkhead of the pump room to this bulkhead of the cofferdam is divided through transverse bulkheads into cargo oil tanks. Now in this case, I have drawn these three transverse bulkheads so that the space has been divided into 4 cargo oil tanks. Now these cargo oil tanks extend from their forward bulkhead to their after bulkhead as far as the longitudinal extent is concerned, and the vertical extent is from the tank top to the upper deck. So this is number 1 cargo oil tank. Now they may have been divided through longitudinal bulkheads which cannot be appreciated in a profile view. They may have been divided by one single centerline bulkhead into port starboard. They may be divided into 3 tanks by 2 longitudinal bulkheads, port, center and starboard. In this ship we are showing 3 tanks, port, starboard and center. So this is number 1 COT, port, starboard and center. Likewise, we can mark number 2 COT, port, starboard and center. Number 3 COT, port, starboard and center. Now, before we draw the number 4 COT, we also have in the tankers, there are 2 dedicated tanks, 2 dedicated cargo tanks, which are designated as the slop tanks, in which the tank washings and the residual oil is stored and to be disposed of as per the requirements of MARPOL. Usually on the tankers, we have 2 slop tanks, one on the port side and the other on the starboard side. So here we have drawn one more bulkhead, and this space represents the slop tanks on port and starboard side. So only on the sides space is used for slop tanks. Usually it depends on the capacity required, but usually the wing tanks may suffice that requirement. But again, the size of the slop tanks will be governed by the applicable rules. Now, Because of these slop tanks on the sides, the length of number 4 wing tanks will not be now up to this pump room bulkhead. It will be up to the forward bulkhead of the slop tanks. So number 4 port and starboard tanks, their boundaries would be from the forward bulkhead of these tanks to the forward bulkhead of the slop tanks. However, as we have said that these slop tanks are only on the sides, number 4 center cargo oil tank, its boundaries will extend up to the pump room. So number 4 cargo oil tank is extending from the forward bulkhead of number 4 tank to the forward bulkhead of the pump room. So you can see number 1, 2, 3 and 4 cargo tanks divided into port, center and starboard. Now on each of these tanks, unlike the general cargo ships where there was a requirement of a huge hatchway on the main deck, here the hatchway requirement is of much smaller size because it only requires for people to enter the tank for different purpose. And each of these cargo oil tanks is serviced by these hatchways which are much smaller, and they have the provision of being closed oil tight, and these are called as the tank domes. And you can see each of these tanks being serviced by their respective tank dome. Then to discharge the cargo ashore, there is a manifold somewhere close to midships of the ship, and around the manifold we have a hose handling arrangement, maybe in the form of a derrick or a crane. So now we can label these additional parts on deck. These three here represent the manifold, cargo manifold. Here we have the cargo hose handling gear, crane or derrick, and then we have tank domes out here. Now what is left are the locations of segregated water ballast tanks. As we said in the beginning, it's a double hull crude oil tanker, but the two sides cannot be appreciated in a profile view. Whereas we can appreciate the double bottom in the profile view, we will not be able to appreciate the two sides in a profile view. The segregated ballast tanks are the spaces between the two sides and the double bottom. In this tank, we have assumed that the segregated ballast tanks are L-shaped, consisting of the space between the two sides and the double bottom up to the center line. So each of these segregated ballast tanks are port and starboard. So for number 1 water ballast tank, you can see the boundaries are coming here in light yellowish shade here. These are the boundaries of number 1 port and starboard water ballast tanks. We have assumed that these water ballast tanks are divided into port and starboard only, unlike the cargo oil tanks which were divided into port, starboard and center. Number 2, you can see the boundaries. Now the vertical extent is right from the deck up to the keel, whereas the cargo oil tanks were ending at the tank top. Water ballast tanks, because they also include the double bottom space. So you can see number 1 water ballast tank, port and starboard, number 2 water ballast tank, number 3 water ballast tank, and we have the number 4 water ballast tank. I hope with this slight change in the cargo storage carrying space of the ship, the profile of a tanker just varies very slightly from the profile of a cargo ship. So the profile is not much different except for the cargo storage space, area or volume, and the cargo handling arrangements. Now we shall learn to draw the plan of a tanker showing the location of cargo and ballast tanks. We shall use the same double hull tanker whose profile was discussed just a while back. And you can see on the screen the profile of the same double hull tanker that we drew a while back is there on the screen for all of us to see. What we'll do is we'll draw the plan outer boundaries of the tank top, because we are drawing the plan at the tank top level. So whatever are the outer boundaries of the tank top of the ship, those we will draw because they will be the outer boundaries of the plan. You can see they are coming on the screen. Here you'll have the forward end of it, then the port side, the after part, and then the starboard side. Now this represents the area at the tank top level of this particular tanker. Obviously on this, the primary bulkheads would be in the same line as the bulkheads in the profile view. So here we have the collision bulkhead, then we have the cofferdam, we have the after peak bulkhead, we have the engine room space, then we have another bulkhead encompassing the pump room, we have the cargo pump room of the ship here. Now we mark the center line of the vessel, so this is the center line of the ship. Now we draw, since it's a double hull tanker, the double sides would be from the cofferdam to the pump room. So now we draw the inner sides of this tanker, and you can see the inner side coming up on the port side. This is the inner side coming up, and likewise we draw the inner side on the starboard side. Having drawn this, now we know which are the cargo areas or cargo spaces in this plan. Now we know in the elevation we had said the cargo spaces extend from this bulkhead of the cofferdam to the bulkhead of the pump room. So longitudinal span is clear here as well. Athwart ship span, which was not clear in this profile, there we said the ship is a double hull tanker. The space between the two sides is used for carrying water ballast. That means cargo oil tanks were contained between the inner sides. That means the transverse extent of these tanks would be from inner side to inner side. So now let's mark out the outer boundaries of the cargo space. It starts from here, contained by the inner boundary on the port side, inner side on the port side, bound by the forward bulkhead of the pump room here, and then bound by the inner side on the starboard side. What has been marked in red is basically the boundary of the cargo space. Now, if you remember in the profile view in this tanker, we said the cargo space is divided into port, starboard, and center by two longitudinal bulkheads. So here we have the two longitudinal bulkheads dividing the space into two wing tanks and one center tank. And these are then divided by transverse bulkheads into number 1, 2, 3, and 4 tanks. So we can see these tanks having been divided. Now we can number them because here we said number 1 COT, starboard, center, and port. So this is the port, center, and starboard. We can label these tanks. Number 1 COT port, 1 center, 1 starboard, 2 port, 2 center, 2 starboard, 3 port, 3 center, 3 starboard. Now here we have the slop tanks on the wings. So here we have another bulkhead extending from the inner side to this longitudinal bulkhead. So this is the slop tank on the port side. We have slop tank on the starboard side. Obviously this is the space representing 4 port. This is space representing 4 port, 4 starboard, and 4 center. You can see 4 center extending right up to the pump room. Then in the engine room, we had the bunker tanks on both sides. They can be divided based on the requirements. So we have the bunker tanks in the engine room region, and this is how the cargo space is in this plan view. Now we can have the complete overview of the space, because in the profile view we could appreciate the vertical span and the longitudinal span, but we could not visualize the transverse span. In this plan we can visualize the longitudinal span and the transverse span, and both put together will give us the complete overview of these cargo spaces. Now, having understood the layout in a plan view of the cargo oil tanks, let's discuss the location and the layout of the water ballast tanks. I'm sure all of us would agree that the forepeak of such tankers is usually used for carrying water ballast. So this out here in the plan view, forward of the collision bulkhead, this represents the forepeak tank out here. Then likewise, the afterpeak tank of these tankers is also primarily used for carrying water ballast. So we have the aft peak tank, aft of the after peak bulkhead. So these water ballast tanks, we are drawing their boundaries in green so that their contrast with the cargo oil tanks can be appreciated. Then the water ballast tanks are in the forward part again here contained by this cofferdam bulkhead, and then they are bound by the outer side. So this space here, now wherever you see the green and red line side by side, that is the same bulkhead. They have just been shown partly overlapping so that we can appreciate the boundaries of the cargo spaces and boundaries of the ballast spaces, but the bulkheads are same. So the space between these two bulkheads we already know is cofferdam, and now we mark out the outer boundaries of the ballast tanks, and ballast tanks are bound by the outer side. So here you can see bound by the green line, we have the boundaries of the cargo water ballast spaces marked out in this region, in addition to the fore-peak tank and the after-peak tank. Now, when we were drawing the profile of this, we said water ballast tanks are divided into port and starboard. So that means in the DB region, port and starboard would be basically the division would be in the DB region. So in the DB part, they would be divided by the centerline girder. So the centerline girder would divide these tanks in the DB part into port and starboard. Now the transverse extent is what we will be able to show. So the transverse extent of these water ballast tanks would be from their forward bulkhead to the after bulkhead. Now after bulkheads would coincide. So let's draw the transverse bulkheads representing the water ballast tanks. So here we have these transverse bulkheads coming up. I'm sure you can understand them. Now we know number one water ballast tank extends from this bulkhead of the cofferdam to this bulkhead out here, and basically in the transverse direction in the DB region they are divided by the centerline girder into port and starboard. So we can mark the extent of these water ballast tanks. I'm sure you'll agree that number one water ballast tank port would have these limits, and here is number one port water ballast tank. Likewise, number one starboard, number two port, number two starboard, number three port, number three starboard, number four port, and number four starboard. Now you may be wondering as to what is the shape, because we have said they are L-shaped. Now to appreciate the shape of these water ballast tanks, which comprise of the space between the two sides and the double bottom up to the centerline girder, forming a L. The shape of the water ballast tanks can be appreciated in the cross-sectional view of the ship. Here is the cross-sectional view of the ship. You can see here the red boundaries here in the cross-sectional view represents the boundaries of the cargo spaces divided by two longitudinal bulkheads into port, center, and starboard. The space between the two sides is used for water ballast, shaded in green, and so is the space between the two bottoms. So this one space from here up to the centerline girder in the DB forms one water ballast tank on one side, and it will have its counterpart on the other side also. I hope if you look at all the three views, that is the profile view, the plan view, and this cross-sectional view, then you will be able to appreciate the shape, size of the water ballast tanks as well as the cargo tanks in a oil tanker. I hope this clears all your doubts, and more importantly, you should be able to draw them. We come to end of this video. Hope you find it useful. Thank you very much for watching Marine Gurukul video series. Please do reach out to us with your comments and feedback through the comment section on the YouTube channel or on our email. ID is marinegurukul@gmail.com. Thank you very much.